In this video, we want to look at a very specific issue. That is, what happens when you raise I to successively larger powers? So if we give consideration to our original I, that came from the square root of -1. If I was to increase to I squared, that would be the square root of -1 times the square root of -1. It's well established at this point, if you multiply a radical by itself, you get the radicand, so I squared would equal -1. I to the third, well, we could write out 3 square root of negative i's, or we know that I to the third is just I squared times I. We know that I squared is -1. We know that I is I, and we get negative I. Increasing to I to the fourth, couple different ways we could think about I to the fourth, but maybe the easiest way would be to do I squared times I squared. We've established that I squared is -1. Multiplying that by itself gives us a +1. So it seems like we're not going to see any real big increases. We're just going to see different variations of maybe some i's and some 1's. So let's keep going, and we'll increase up to I to the fifth. Well, I to the fifth is just I to the fourth times I, so no need to go back to the square root of -1 in our explanation. I to the fourth we've established is 1. I is, of course, I. 1 times I is I. Moving to I to the sixth. I to the sixth is just I to the fifth times I. Well, I to the fifth was I. I is just I, of course, as we keep seeing in all of these examples. I times I is just I squared, which we've already established is -1. Moving on to I to the seventh, that's just I to the sixth times I. We've established that I to the sixth is -1. I is, of course, I, and so we get -I. And lastly, for this example, we're going to say I to the eighth is just I to the seventh times I. We've established that I to the seventh is -I. I is, of course, again, just I. I times I is I squared. I squared is -1. Negative of that leaves us with a +1. There's actually a lot of different ways you could explain I to the eighth. You also could use I to the fourth times I to the fourth, because we know that's just 1. So it's 1 times 1, also giving you a 1. So a couple different ways to think about that one. But that's not the important part. The important part of this is that you should notice what's happening at this point. We've gone through 8 examples, 1 through 4 as the power, then 5 through 8. And you should notice that there is a similarity between the simplified versions in each of those columns. Namely, that we see a repetition. And that is not by accident. Incorporating an extra I serves that function of incorporating an extra square root of -1. And as you're doing that, you should expect to see things like sign changes. You should expect to see I brought back in. You should expect to see I eliminated as it gets multiplied by another I. So it shouldn't be a surprise that our answers stay relatively small. And it shouldn't be surprised that it's some combinations of 1's and i's. But maybe the part that's surprising is the fact that we see that perfect repetition 1 through 4 and 5 through 8. So looking at what we have here in terms of specific examples, we got 1 and 1 and -1 and -1 in those 4 situations. I squared, I to the sixth, I to the fourth, and I to the eighth. It might not surprise you then that if we have an even power of I, then we are guaranteed a result of 1 or -1. Conversely, look where we have our I results. Here's I to the first, here's I to the fifth, here's I to the seventh, and here's I to the third. We should expect odd powers of I to produce either just an I or a -I. Going back to the even powers for just a second, we don't have, they're not always just, they're following a pattern, but they're not necessarily a pattern that's easy to verbalize. So I got 1 at I to the 4th and I to the 8th. And I got -1 at I squared and I to the 6th. It might not be a bad idea to pause the video right now and kind of give some consideration to when did I get 1s and when did I get -1s. Well, if you thought about it, you're getting the 1s at the ends of these groups of 4. So what is happening at the ends of these groups of 4? Well, this is a 4, this is the 8, the next one would be a 12, and then a 16. I think it's fair to say then that we're getting the results of 1 when we have a power that is a multiple of 4. Now, thinking about the -1s, I can't just say evens because that counts the 4 and the 8 and the 12 and the ends of each of the groups. But what are these numbers? Well, they are even, but they're the evens that are not multiples of 4. So we're going to expect our -1 result for powers that are even, but not multiples of 4. Because if the number was a multiple of 4, then it would fall into the other category. So yes, all over on the left-hand side is all of our evens, but expecting the multiples of 4 to give us a result of 1. Looking at I and -I. So where did I get my i's? I got my i's at I to the 1st, I to the 5th, and the next one will be I to the 9th, then I to the 13th. Sure, those numbers are all odd, but we want to think about them in relation to the multiples of 4. It looks like I keeps starting the group. So I to the 1st, I to the 5th, I to the 9th would be the top of the next column if I was to do it again and again and again and again. So I should anticipate an I when my power is 1 more than a multiple of 4. So if you're thinking about it in that column approach, it's the one that starts the next group. Let's look at our negative i's. Here we have our negative i's, right here and right here. That happened at I to the 3rd and I to the 7th. Okay, so they're also odd. I'm on board with that. But I can't just describe them as odd because of these two up here. But I see where they're positioned at in the groups of 4, and I see them positioned directly in front of the multiple of 4. So sure, we're still going to put them into the odd category, but we're going to say that their power is 1 less than a multiple of 4. They are fitting in right before those multiples of 4. Let's look at a couple of examples. First, I to the 17th. I to the 17th is an odd power, so I know that my result is going to fit into that category somehow. Is 17 1 more than a power of 4 or 1 less than a power of 4? 17 is 1 more than a power of 4. It would be the beginning of a group. So 1, 5, 9, 13, 17. I to the 17th is just I. Didn't require me to write everything out. I knew that that was the case because of the pattern. Looking at another one, let's try I to the 704th power. You want no part of having to write all of that out. So you check to see if 704 is divisible by 4. Well, 700 is divisible by 4. Therefore, 704 would be divisible by 4. Therefore, 704 is a multiple of 4. And I to the 704th has a value of 1. Understanding the pattern of the results and understanding the order and sequence. And if at any point you forget it, you could just rebuild it. It's not as if you have to memorize it. You can rebuild this by going through the same examples that we did. As long as you know I'm going to be looking for some kind of pattern in the results. But if you're able to do that, then you can identify the value of any power of I significantly higher than just those first 8.